Welcome to the Deep Dive. Today, we're unpacking a real high-stakes paradox in aviation, the circling approach.
It is a paradox, isn't it? It used to be this, totally routine part of flying.
But now it's rarely flown, almost like an aviation dinosaur.
Huh.
And yet, if a pilot has to do one, it's suddenly one of the most demanding, high-skill things they can do in the cockpit.
It's the ultimate test, really. A mix of pure visual skill and rigid procedural knowledge. Our sources for this, things like JAR Ops and the Airbus Standard Operating Procedures, they make it crystal clear this is not a casual maneuver.
Absolutely not. It demands incredible precision. You're swapping the certainty of automation for pure manual visual flying.
Exactly.
So our mission today is to take you inside that cockpit. We're going to lay out the rules, the definitions, and the step-by-step process for this maneuver. We want you to really get not just what the pilots are doing, but why.
And we should probably start with the most basic definition. So a circling approach is what happens when the runway you need to land on is different from the runway you use for your instrument approach.
Right, so maybe the wind shifts last minute or there's other traffic. You fly the ILS for, say, runway 36, but you actually have to land on runway 18.
Precisely. You follow that instrument approach down as far as you safely can, and then you have to execute this big, low-altitude turn to line up with the correct runway.
And that turn, that's the circling.
That's the circling. And it's really crucial to distinguish between a circling approach and just a visual approach.
Okay, what's the key difference?
A circling approach is specifically the visual phase of an instrument approach. You're still tied to the safety limits of that initial procedure. A general visual approach means you've, abandoned the instrument procedure altogether and you're just flying by looking outside.
Got it. So circling is still tethered to an instrument procedure's safety net.
Exactly.
Okay, let's jump straight into the real pressure cooker then. The rules of entry. You've leveled off, you're flying towards the airport at your minimum altitude. When do you actually commit?
This is the go-no-go decision.
Yeah.
It all starts at or above the MDAH.
And MDAH is the minimum descent altitude or height.
Right. It's the absolute floor. You cannot go below it until you meet some very specific visual criteria. So you keep flying the instrument track until 3 mandatory conditions are met.
3 conditions. Okay, lay them out for us.
Condition 1, the pilot has to be confident that visual contact with the runway, or at least the runway environment, will be maintained.
Not just for a moment, but for the whole thing.
Throughout the entire circling procedure, it's not just a glimpse, it's a commitment. Lose it for a second, and you're in trouble.
And what happens if you do, if you lose sight for just a moment?
It's an immediate missed approach. No hesitation. The moment you lose that visual reference, you're no longer guaranteed to be clear of obstacles. You have to start the escape maneuver right away.
Wow. Okay, so continuous visual contact. What's number 2?
The aircraft has to be completely inside the prescribed protected circling area before you even start the turn.
Which is that invisible box in the sky that keeps you safe.
That's the one. And the third thing is that the crew must be able to tell where the aircraft is relative to the runway just by using external, real-world references.
So you're using your eyes, not just staring at the screens.
The screens are there for a cross-check, but this is a visual game.
Okay, so you have to meet all 3 of those. But what if you get to the end of the line for the instrument approach, the missed approach point, the MAP, and you still don't have the runway in sight?
Then the decision is made for you. It's a mandatory missed approach. You follow the procedure for the instrument approach you were just flying, no lingering, no trying to find it, you go around.
Now, the sources mentioned something technical here, the ILS GP out procedure, MAPT. That sounds a little confusing. Why reference the procedure without the glide slope?
That's a great question. It's a key safety detail. When you're planning to circle off an ILS, you've leveled off at the MDAH.
So you've already abandoned the vertical guidance, the glide slope.
Exactly. You're just using the horizontal guidance, the localizer, and your altitude. So the relevant escape point, the MAPT, becomes the one for the non-precision version of that approach. It's all about having the right safety boundaries for the procedure you're actually flying.
That makes perfect sense. And speaking of that floor, the NDAH, you absolutely cannot go below it during the circle, right?
Correct. You fly the maneuver at or above that altitude. You only start descending below it once you have the landing runway's threshold in sight and you're in a position to make a normal, stable descent to land.
Okay, let's talk about the physical space this takes up. We mentioned the protected area. That area changes depending on how fast the airplane is, right?
It changes dramatically. It's all based on the aircraft's category, which is defined by its speed. The faster you are, the more room you need to make the turn safely.
Let's put some numbers on that. Say a Category C aircraft, like a medium jet, versus a bigger, faster Category D?
Okay, so a Cat C aircraft is maneuvering around 140 knots. The ICAO standards give it a circling radius of 2.83 nautical miles.
And for the faster Cat D, which might be going up to 165 knots.
That radius jumps to 3.7 nautical miles. It's a huge difference. You need nearly a full extra mile of protected airspace just to make the turn.
Wow, that's a massive increase. What's the risk if you stray outside that protected zone?
Terrain, simple as that. That radius is calculated to guarantee you'll be clear of any obstacles. Step outside it, and you lose that guarantee. That's why maintaining visual contact is so critical. Your eyes are what keep you inside that safety bubble.
The sources also mention HAA, height above aerodrome. That scales too.
It does. For Cat C, it's typically 450 feet. For Cat D, it's 550 feet. A faster plane needs a bigger, slightly shallower turn, so you need a higher floor to ensure you clear everything in that larger protected area.
It really shows this is a science, not just an art. Okay, let's get into the weeds, the step-by-step Airbus procedure.
The prep starts way before the approach even begins. The crew is checking charts for terrain, looking for any special restrictions. Some airports don't even allow circling.
And they calculate their specific MDA.
Right. And then comes a really critical technical step. Setting up the secondary flight plan, the SEC FPLN.
The ghost plan, you called it. Why is that so important?
Well, your active flight plan is for the straight-in approach, right? So you copy it, and then you edit that secondary plan to show the actual landing runway. It's a safety tool. It lets you use the navigation display, the ND, for situational awareness.
So you can see where you are relative to the threshold and terrain.
Exactly. But, and this is a huge but, you are explicitly told not to use the NAV guidance from that plan to fly the circle. It's a map, not a flight director.
A map overlay for cross-checking only.
Yeah.
Okay, so you're flying in, gear down, flap set. What are the flight directors showing?
For an ILS, you're probably in heading vertical speed. For a non-precision, maybe track flight path angle, the goal is just to stay on the instrument course until you see the runway.
Then you hit the MDA, that hard floor.
You level off, and then you start setting up the turn. You'll arm the initial 45-degree turn away from the straight-in track.
And this is the moment of truth, if you see the runway.
You pull the heading knob and start the turn, if you don't see it.
It's an immediate go-around.
Go around. And at this point, the proper missed approach is still active in the flight plan, so the automation can still fly the escape route for you.
Okay, let's say we are visual. We've made that 45-degree turn. Now you're trying to fly parallel to the runway on the downwind leg. How do you time that?
Airbus gives a rough guide of about 30 seconds from when the wings level out. But that's, highly approximate. You have to constantly adjust it for wind.
You use the wind indicator on the ND for that?
Absolutely. A strong headwind or tailwind can push you way off track. This is where the visual part really kicks in. The timing is just a starting point.
This sounds like where a pilot really earns their stripes.
It is. Once you're established downwind, you take the big procedural step. You activate the SEC FPLN.
The ghost plan becomes active.
Well, active for reference. You have to keep the discontinuity in there so the plane doesn't try to fly somewhere. And then, critically, you disconnect the autopilot and turn off the flight directors.
You're fully manual. You are the flight management system now.
You are. The next timing point is when you're abeam the runway threshold, ABM we call it. A rough guide from there is to start your final turn after about 3 seconds for every 100 feet of altitude you're at.
And the navigation display is now just a safety net.
A very sophisticated one, but yes. It's just for checking your offset, assessing wind, and watching for terrain. And the most critical instruction is that once that SEC FPLN is active, the automated missed approach is gone.
Any go-around after this point is completely manual.
Completely manual and selected by the pilot.
Okay, the final turn to line up with the runway.
You want a standard bank angle, about 25 degrees. You hold your altitude, the MBA, until you're sure you can make a normal descent to the threshold. The key is to be stable, fully configured for landing, on speed by 400 feet above the ground.
That brings us to what visual actually means. How specific does JR Ops get in defining visual reference?
Oh, it's incredibly specific, because this is the legal basis for going below that MDAH floor. The pilot can't descend unless at least one item from a long list is distinctly visible and identifiable.
Let's hear the list.
It includes things like the approach light system, the threshold itself, the threshold markings, the lights, the visual glide slope indicator, touchdown zone markings or lights, runway edge lights. It's a very long checklist.
Wow. So if I can see the green threshold lights, I'm good. But if all I can see is the airport beacon flashing a few miles away, I have to go around.
That is the exact threshold. And the procedure for going around if you lose visuals while circling is probably the hardest part of this whole thing.
You have to fly the missed approach for the initial instrument approach you started with.
Correct. But you might be on the opposite side of the airport.
So if you're downwind and lose sight, the procedure says you have to make an initial climbing turn toward the landing runway. That
Yeah.
sounds wrong. Aren't you turning towards the airport and potential obstacles?
It sounds counterintuitive, but it's a critical safety design. You turn inward toward the runway to keep yourself centered over the aerodrome. That's the safest place to be, inside the protected area, before you climb out on the published missed approach track.
So you turn in to stay inside the safety bubble rather than turning away and potentially flying into unprotected terrain.
Exactly. And because you could lose visuals at any point in that circle, the pilot has to figure out on the fly how to maneuver back onto that escape track, all while staying inside the zone. It's incredibly demanding.
Compounded by the fact that the go-around is now fully manual.
Fully manual, must be flown selected, the automation is gone.
The sources also forbid using things like PBDs. What are those?
PBDs are point-bearing distances, basically manual waypoints a pilot can create, but the rule is firm. This is a visual approach. You can't use homemade waypoints, you can't use NAV mode, you can't use the autopilot below the circling minimums, you have to fly using what you see outside.
This whole deep dive really drives home the complexity. It's intense visual awareness, sticking to that MDAH floor like glue, and this huge procedural shift with the SEC FPLN that makes it so challenging.
And what's really fascinating is that the sources all note this procedure is slowly being replaced
Replaced by what?
by RNP approaches. Required navigation performance. They're these satellite-based procedures that can create a precise, curved path right to the runway, often with even lower minimums than a circling approach.
It really does raise a big question for you to think about. Given that all the complexity of the circling approach comes from the need for human visual skill and quick manual maneuvering, what is its gradual replacement by these hyper-precise automated RNP approaches tell us about the future of flying?
I mean, what is the future balance between human judgment and procedural precision? Are we moving toward a day where we trust the GPS signal more than a pilot's eye at low altitude? It's a huge discussion.
A compelling one for sure. That's all the time we have for this deep dive into the demanding world of the circling approach. Thank you for joining us.